All right, let's talk about the peanut butter and jelly of networking. By the end of this session, we'll be able to describe the software-defined access network layer. Can you imagine opening up a sandwich and finding out you only have peanut butter or you only have jelly? That's not a complete sandwich. Well, the same thing is true with the underlay and the overlay. Without both of those, we don't have a complete software-defined access network. So in this video, we're going to explore the SDA Access Network Layer, which consists of that overlay and underlay. We keep talking about this concept of an overlay versus an underlay, and we're going to talk more about it in more detail here in this video. So again, we're starting with an underlay that's darkened out so we can draw over it. And as we know by now, we're going to be creating tunnel interfaces among all of the edge switches in this environment. These tunnels are going to be formed via VXLAN. VXLAN defines the data plane in an SD access environment. In fact, when we're talking about the fabric, we're talking about these VXLAN tunnels. Now, these VXLAN tunnels are great and all of that, but how do we know which VXLAN tunnel to use? Well, if you'll recall, we talked about these control plane nodes sitting out here. Maybe they're routers or switches that ideally they're dedicated for the purposes of managing this control plane. And we are using a Cisco protocol called the Location Identifier Separation Protocol, or LISP. LISP is going to keep a mapping database of all of the endpoints that exist out there and which switch they're connected to. Now, the data plane and control plane, we're used to those conversations, but what about this concept of a policy plane? We need to be able to enforce policies in this infrastructure. It's one of the advantages of deploying it. And we've mentioned that we'll use ICE to help us with that, but specifically the technology is Cisco TrustSec, or CTS. And that will serve as the policy plane for our fabric. So let's walk through an example here. Let's say we have user A wanting to communicate to user B. So user A sends a packet up to its parent switch. That would be a fabric edge node. And it would not be prudent of us to store all of the user information for the entire network on every single fabric edge node. And so this fabric edge node doesn't know where to go, but fortunately we do have an authoritative source that would be the control plane nodes. So we're going to send a request to the control plane node to find out which switch ID we should send that traffic to. And we're going to get a response back that says, for example, hey, send that to switch 2. At that point, we are going to send across the VXLAN tunnel to get to switch 2 so that it can forward that traffic down to user B. Now that's great from a networking perspective. We've formed end-to-end connectivity. However, let's not forget about the policy plane. In order to facilitate policy enforcement, we need to tag that traffic. So this switch is going to tag the traffic accordingly, and then when switch 2 receives this traffic, it's going to enforce the policy on that tag. So for example, if user A is not allowed to talk to user B, we're going to drop that traffic. Meanwhile, any kind of quality of service policy will be respected by the underlay because this tag is visible to the underlay. So as far as the overall fabric is concerned, we have three main components we need to remember: VXLAN at the data plane, Lisp at the control plane, and Cisco TrustSec at the policy plane. So what about this underlay? What's going on with it? For example, where do these hardware components come from, and how do we configure them in order to support this fabric? Well, the good news for the underlay is this can be the existing network. And if that's the case, we're usually going to configure this manually as opposed to automating it through DNA Center. So this can be layer 2 or layer 3. It doesn't really matter which one, although Cisco does recommend layer 3. Additionally, this can be configured with any IGP. However, Cisco does have a recommendation for that, and they recommend the use of ISIS. And last but not least, we need to support jumbo frames on these switches because VXLAN has a header packet size of 50 bytes. And so because of that, we need to expand the MTU by, you guessed it, 50 bytes in order to support VXLAN traffic. So that's great and all, but what if we're building this as a brand new network, what they call a greenfield deployment? Well, if that's the case, then we can automate this process via DNA Center. All of our devices will power on and use plug and play for bootstrapping, meaning they're going to pull their configuration from DNA Center. And these devices will receive IP addresses from a configured pool. Again, this network really only needs to support layer 3 functionality, and really the things we mentioned down here. We need to support the MTU, and we need to have a routing protocol. And so all of this can be pretty straightforward automated via DNA Center. It will push the IP addresses via that pool. It will push the routing protocol configuration, and it will make sure that jumbo frames are supported. So when it comes to software-defined access, the network layer is going to consist of both the overlay and the underlay, and we need to understand the key components of both. And with that, you are now able to describe the SDA Access Network Layer. I hope this has been informative for you, and I'd like to thank you for viewing.